In this video, we will introduce a simplified version of Green's theorem. Green's theorem states that there is a one-to-one relationship between an area and its circumference. What that means is that when you draw a closed path on any surface, the area inside this path can be calculated just by using the information on the path, with respect to a fixed point somewhere on the plane. Now we're going to show you the formula that describes Green's theorem. We're not going to lecture you on how this formula is driven, but we're going to give you a simple description of what it represents. The left-hand side of this equation tells us that if you have a closed area, the area can be calculated by putting small rectangular tiles on the surface. If you place enough tiles of the same size on a surface, and you know the number of tiles, then the area of the closed region can be calculated. The double integration on the left-hand side of the equation does the summation. The right-hand side of the equation tells us that you can calculate the same area just by walking around the area's circumference. If you're not well versed in calculus, this will not be that obvious. However, that is what the right-hand side of this equation is telling us. Now let's show you how and why this formula works. Here we have a map of the United States. Now let's focus on Colorado. We're going to show you how the area of a state or multiple states can be calculated with Green's theorem. As you can see, we have a green and a red circle on the screen. The center of the red circle is a reference point which will be used to calculate the area of the state or states. The green circle represents points on the circumference of an area to be calculated. Let's move the red circle somewhere on the map. The position is not important for the equation. However, it is required by the right-hand side of the equation that we saw earlier. Now we will move the first green circle to a corner on the state of Colorado. Since Colorado has a rectangular shape, the area is much easier to calculate, and we can take bigger steps on the circumference. Notice that once we place the first green circle on the circumference of Colorado, another green circle appears close to the red circle. These additional circles will appear until we have completed our journey around Colorado. Notice what happens when we begin to drag the second green circle around the map. When the second circle is rotated clockwise from the line joining the red circle to the first green circle, the triangle joining these three circles is red. This means the area of the triangle is positive. However, if the second green circle is rotated counterclockwise, the area becomes green, and this corresponds to a negative area. When we place the third triangle on the next corner, the color of this triangle is neither red nor green, but some color in between. Actually, the color of the last triangle should be green. However, there's a red triangle beneath this green triangle. So when the green and red colors are mixed, we get this area of darker green. In short, whenever we see any other color other than red or green during a rotation, it means that the two areas are canceling one another out. Now we place the fourth green circle here. Notice the green area which is not yet canceled. This is because we have not closed our loop on the circumference. Finally, we place the last green circle on top of the first one where we started our journey. As you can see, the approximate area of Colorado is shown in the output field. Notice there are no more green circles to be placed. This is because the program knows that we've completed our journey around the circumference of Colorado. Since the path is closed, the area is fixed, and it is independent from our starting point. Now let's drag the red circle. As you can see, the area is changing even ever so slightly. Although it's changing, it's not changing by a lot. So what's happened? We said that the area is independent of the location of the red circle, but apparently it's not the case. It should be independent from the red circle, but we deliberately did not place the final green circle exactly on top of the first green circle. This small deviation in their placement is causing this error. Let's make this quick fix and move the red circle. As you can see, the area is fixed no matter where we move the circle. And we see the one-to-one relationship between the area and its circumference. When the red circle is inside the border of Colorado, all the triangles have a positive value indicated by their red color. When we move the red circle outside the borders of Colorado, some of the triangles are green, meaning their values are negative, but the total area is still unchanged. Now let's see if we can calculate the area of two states which do not have a common border, such as Nevada and Colorado. As you can see, we've just calculated the total area of Colorado and Nevada. For further information on Green's theorem, please visit the link on the bottom right. We thank you for your time and visit us soon for more videos.